Stepsons, have you ever heard about a 3D printer? Have you been curious what a 3D printer can do? Well, my son Nicholas wanted to get one for his last birthday just a couple months ago, and so we got him one, and we're going to take this episode to show you what it can do. I'm actually going to let Nicholas give you an overview of what you can do with a 3D printer while we make a bracket that I can use to hang my helmet on.
So the first thing you need to do is find a 3D model of the object you want to print. You can make that yourself or you can just find it online. What I like to do is go to thingiverse.com. This is the most popular website that I've found to find models. And then you just search for what you want. So in this case, I just typed motorcycle and it came up with these results here. And I thought, hey, a helmet wall bracket might be pretty cool. So you go here, and then this is just a model that someone else designed and uploaded, and it's got pictures, but what you want to do is come to the thing files here, and you can download the files for this object. So you have to take that file and actually put it in a slicer program is what it's called. What this does, my 3D printer just came with one. You take the 3D object, put it in there, and then this can map out instructions for the printer to actually make the object. So when the printer's actually printing, all it's doing is following directions. It doesn't know what it's printing, it just has a series of coordinates. So that's what this program does, is it takes the object and makes those instructions for the printer. So you can scale. This program has the tools down here. You can scale to like 75%, for instance, and that just uniformly scales the whole object there. You can also rotate it but in this case, since it's got such a sharp bend there, you'd want to do support structure if you did, and all that does, we can view it how the printer will see it here. And what that does is, I guess it doesn't need it here, but it would add some easy to break away plastic here to support the print while it's doing that. It was better how it was, so I'll just reset the position and let's see, rotate it back. And so yeah, most of the case, the way that you can get more surface area on the print bed, which is just the base here, is better.
Okay.
And you can see this barely fits on the print bed. This is the size, or this size is specific to my printer, so you'll want to make sure that whatever you're printing will fit on your print bed. So once you have this how you like here, then you just go to File up here, Save G-code, and you want to save that to an SD card that you can use with your printer. So I've got mine right here, and I just save that in here. I've already got this somewhere in here, just right there, so I'm not going to save it, but you just want to save it anywhere on your SD card, and then you can take that to the printer. Okay, so you take your SD card that has the G-code file on it, plug that in. So this is the Ender 3 Pro. It's, from what I understand, pretty much the most popular consumer budget 3D printer. So this is one that a lot of people are going to have. But yeah, so once you put the SD card in there, you're going to flip on the printer there. You'll see the screen turn on. You'll just click it in and you can go to print from TF here. You want to make sure before you do that, you hit prepare and hit auto home. That just makes sure that all three axes of the printer are ready to go. Then you go to print from TF here, and then you just find your file. So helmet bracket right here. And this is just going to print in whichever color you have loaded of filament. Right now we've got black. There are also a lot of other colors you can get, but we're going to do black here because it's going to look best on the wall. Once you're ready to do that, you just go ahead and click on that file. And now what it's doing is it's heating up the print bed and the extruder nozzle so that it will be ready to print. Heating up the bed keeps it from peeling once it's once the plastic is melted onto the bed. And that takes a while. So everything that you see on the printer that is orange has been printed by the printer itself. Yeah, I made this knob here. I made these cable chains to keep them nice and neat. I made the knob here. I made these drawers to hold on to the tools that came with the printer, as well as extra parts. I made this to keep it looking fresh. And then I printed up here the roller for the spool to keep it rolling smoothly. So you can really, just printing accessories and upgrades for the printer itself, you can get an idea of how this would be useful for other things. So that's the print bed right now. It has to get the print bed up to 60, and then after that it heats the nozzle up to 200, and those are Celsius. So when I say it takes a while, it does take a while. The nozzle is that part right there that's touching the print bed currently. That whole box is just to heat it up and keep it from overheating, because it's just like a hot glue gun. They want the tip to be hot enough to melt the plastic that's being fed in through here. So what this is here is this is the extruder. This is the motor that pushes the filament through, and then it pushes it into this tube that then goes down through the top of the nozzle, which heats it up, melts it, and puts it in place. This is another tool holder here. It just keeps the scraper that you can use to get prints off the bed if they stick too much. It just holds that back here. The slicer estimated 7 hours. It's not always 100% accurate, but as it prints, it will give you a percentage complete, as well as how much time has elapsed since you started it. So you can use those numbers to get an estimate of how much longer it will take as well.
Cool.
So what it does first is it's just printing a loop around the object. That's just to prime the nozzle, make sure any filament of the last color you used gets removed before it starts the actual object, as well as you saw it didn't start printing for like half of the time there. So it's just to make sure that any air bubbles also get removed. The first line was the priming line, the second line is the start of the object. So now it's drawing the outline of the object. After it's done with the outline, it will start filling it in, and then it will just move up layer by layer and keep doing that. Since this isn't that complex of an object, it's not going to be much different throughout the print.
Alright, Nicholas, we got it done. It's finished printing. It's black on black, so it was kind of hard to see, but what do we do now?
So now the last step is just to take it off of the build plate. You can notice it's kind of stuck on there, so this printer has a magnetic build plate that you can just pop the whole thing off and then easily peel the object off of that. And then you want to pull off any stringy plastic and then just put it to use however you intend. So you want to take any other plastic that was left on here off.
So now we're going to go we're going to go mount this onto the wall in the garage so you can see how this gets used.
So I'm going to print a little key hook rack to hold all of my keys on.
Okay, and we're going to do that in a different color.
Yeah, so you can see it more easily. Okay. And this way we'll get to show you the process of switching out the filament as well. So first step you want to do is turn it on, and then once it's on, you're going to want to once again auto home it just to get everything set back where it goes. Get all of the build plate and stuff out of the way. Z-axis can be pretty slow. And then you want to go and turn on the nozzle heater up to the normal print temperature, and this printer is 200 degrees for the nozzle. And you want to turn it onto that and just get that heating up. And then that way, when you go to take out the filament, it was all melted in the tip when you finish the last print, so it's a lot harder to take out unless you melt it down, make it soft again. That way it lets go and you can just pull it right out smoothly. So that's going to take a second to heat up. And so once it reaches 200 degrees, then you're going to want to pull out the filament from the extruder here, and that just comes out easily when it's warm. And then you can pull the whole spool off the top there, just like that. You want to wind it back up for neat and orderly storage, just like my dad always taught me. And this is a new color that I haven't used yet. It's just green. Every new spool that I've gotten has come in a plastic. So my printer came with this pair of cutters here, and snip off the end like that, and you can see leaves that at a nice sharp angle there, and that helps it get itself into the hole easier. Once you've got it in, you can start seeing it come through the clear tube there. You start feeling resistance. That means it's reached the nozzle, and then you're good to start printing. Yeah, now we're ready to start printing. Just find the file that you want to print. Keykeeper is the one that I want to print this time. And now, since we only heated the nozzle, it still has to heat the print bed before.
All right, stepsons, now that we've got this printed, we're going to mount it on the wall. And I'm envisioning putting this here. This is a helmet holder. Nicholas recently bought a motorcycle, which meant I had to buy a helmet so that I could ride his motorcycle sometimes. So when we're mounting stuff, we got to find the stud, where the stud is in the wall. But go watch the video for hanging a TV mounting bracket that we did, that Nicholas and I did, because that shows you more about finding this and using this tool, which this one happens to be a stud finder here. But I'm going to put this on and we'll just show you how this works again. So once it's calibrated, then you move over in the green light center where it senses a stud in between, and right there, which not surprisingly is right here. It has trouble over here because there's an electrical conduit coming down here. It's not that it has trouble, but it senses the electricity in the vicinity and it gives us a warning, because theoretically you don't, well, not theoretically, you don't want to drill into an electrical conduit. However, the stud is right here that I want to mount to, so I'm going to do it anyway. I'm not going to do it anyway, but I'm going to drill into the wood even though the electricity is on the side, and I'm going to find it by measuring from right here. 16 inches, you notice how that's red right there? Standard distance between studs in a framed house. In fact, if you measure from that one to this one, you'll see that it's right on 48, which is 4 feet, but that's also a standard distance. So all I have to do is put it in the middle of this tape here and come to the next one, which would be here. So this stud probably goes down this side of the plug. So I'm going to put this up here with the already marked location for the stud. I know the next one's going to be centered right there. Just hold that there, and that's centered on that, and then I can mark here as the center for this one. We're going to mount this here, and so that should be good. And that's another way to verify, is just by knocking on it. You can tell the sound difference if there is a stud there. I do have power here, so that is a cautionary thing. The power does not go between the stud and the drywall. It will be next to it. As long as I'm right into the stud, that shouldn't be a problem. So, drill bit. The way that I choose the right diameter of a drill bit is to look at the screw next to the drill bit, and you don't want it to be larger than the outside ridges of the screw. Otherwise, there's nothing for it to grab into. So you really want it to be about the same diameter as inside of the threads. If you look at a screw, you can see the straight through diameter between the threads. That's what you'd want, or maybe just a little bit smaller, because that's what's going to get the engagement and hold on to it. But if you try to go straight into wood that doesn't have a pre-drilled hole in it, you'll split the wood or you won't get it in, and you'll end up cussing and not being happy. I don't have the ideal drill bit, but this one should work, so we're going to go ahead and put that in and drill our first hole. And the way you do this is you hold the chuck while you're screwing it in, and you see how the teeth close down. Now you don't see because my hand's there. And once it starts to grab, just hang on to the chuck and tighten it down that way. So that should be good. The other thing I'm going to check on this is if I go into the wall, how deep is the hole going to be relative to the screw? And that's about right too, probably 3/4, maybe just a little bit more, but you want to leave some that's not drilled into the wood. And again, that's going to make sure that your screw really holds it well. So now I've got the middle marked here. I'm going to, I think that's about the height I want it. That's about where it is. Got a spot there. Always wear safety glasses when you're using power tools. All right, now I'm right-handed, it's on my left side. I'm just going to do it this way. And we missed the stud right here. It didn't go into anything. Right up here is when we measured when we built this shelf, and that's into wood, and that's into wood. And so I just came over probably a 1/2 inch, and that one actually is into wood. So now I'm just going to hold this here. I'll line it up here in the first hole that we've done and make sure it's straight up and down. Mark it here to get the second hole drilled, and then we can mount it with our safety glasses. This is the impact driver. It's just a little easier than doing them by hand. Though with this upper one, I probably will have to do it by hand because there's no room for the screwdriver to get at this, or the impact driver to get at that, because the frame itself, or the part itself, is in the way. So we'll put this one in by hand. Too tight. Actually, I think I need the smaller screwdriver from in the house, so we're going to grab that. All right, so this screwdriver is short, so it will fit between where the part would hit it otherwise and the screw. The problem is it's just hard to do manually. All right, so now the top one's in. I'm just going to sink this bottom one. All right, now that's mounted, and that will let us keep hanging from the wall. So now it won't take up desk or surface area on the workbench when we do it. All right, so this is an example of a part that we made on your printer that's functional, that we can use to hang the helmet on. So Nicholas, a couple questions for you. Why is it you wanted a 3D printer?
Because they're cool.
So if someone was going to buy a 3D printer, what would you suggest that they do?
I'd say go for the one that fits your budget the best, because they all pretty much do the same things. Unless you get like really expensive, then they don't really come with any extra features that make it worth it.
The expensive ones?
Yeah, those ones can have like multiple nozzles or something.
And they don't have extra features?
They do.
They do, okay.
Unless they get expensive, then they don't have extra features.
All right, so now you've seen a little bit of Nicholas's 3D printer, and you get an idea of how they work. And I don't know that you'll be buying a 3D printer, but if you've been curious about it, now you maybe know a little bit more. Always remember, stepsons, the 2 messages I want you to get from every video that I do. First is that you can succeed. Even though your dad may not be in your daily life, you can choose to succeed anyway. And always remember the second one, your stepdad loves you. I'll see you on the next video. Oh, gotcha. You're using 2 negatives on me.
Yes.
Unfortunately, I don't get fast forward through it. I have to sit here and screw it in. Since the stud finder won't find the center of it here because of the... So now we've got this that was printed, and this is actually a helmet holder for Nicholas's motorcycle. No, this is not a helmet holder for his motorcycle. All right, cut it.